All right, on to 2.3. This will be a much shorter video, a little less talking and a little more action. Okay, so exploratory data analysis. What is exploratory data analysis? Well, we have this entire paragraph kind of explaining, but essentially, it's ways where data scientists can analyze and investigate data sets and summarize their main characteristics. Okay, we're often using visuals. So we just use visuals like histograms and frequency tables. Now we're going to talk about another visual that we can employ. Okay, we can also determine how we can manipulate data, sources to get the answers we need. We can look at patterns, try to look for anomalies, test hypotheses, and so on. Okay, so that's kind of exploratory data analysis. All right. Mainly what we're trying to do is we're trying to see what data can reveal beyond formal modeling or hypothesis testing. Okay, and we want to have a better understanding of the data that we're looking at in the variables. Okay, so we're going to look at 4 different types of EDA, and I'm going to talk about each of these, and I'm actually going to refer to this website because this website does a pretty good job of outlining each of those. So let's see if I can share this website. Okay, the website, I'm looking at it right here. So hopefully you can see that screen and we can follow along with these different types of data. So univariate non-graphical. Okay, that's our simplest form of data analysis. The data being analyzed consists of just one variable, and that's what this means. Univariate means one variable. Okay, since it's just a one variable, it doesn't deal with causes or relationships. Okay, the main purpose of univariate analysis is to describe the data and find patterns within it. All right, so for example, maybe we're just looking at the weight of something. Well, the only variable is weight. We just measure different weights. Maybe we're talking about weights of pineapples, I think was an example we used a while ago. Well, we could study the weights of different pineapples that we're selling at the store. And that's the only variable. We can analyze the data, look for trends and patterns within that. Okay, univariate graphical data. Non-graphical methods don't provide a full picture of the data. I know I'm just reading, but kind of summarizing, or I'll try to add on things as I'm reading. Graphical methods are therefore required. Okay, common types of univariate graphics include, so stem and leaf plots, that's what we're going to look at today. Histograms, which we did yesterday. Box plots, okay, like a box and whisker plot showing a 5-number summary. So we've done some of these things in the past, actually all of them you've seen before, with univariate graphical data. Okay, again, univariate meaning single variable, but we're showing it's graphical, meaning we're getting a visual now representing the data. And then multivariable non-graphical. Multivariate, you could guess, multiple variables, right? We have 2 things or more that are affecting each other, or there might be relationships between them, or cause and effect. Okay. And then multivariate graphical, that uses graphics to display relationships between 2 or more sets of data. The most used graphic is a grouped bar plot. We talked about that, like a double bar graph. That's an example. So we could do things like that. Maybe I'm comparing males to females in a certain aspect. Maybe it's life expectancy, like the one we did in class. That would be multivariate graphical data, or one example of it. Okay, other types of common multivariate graphics include, well, we talked about all these yesterday. Scatter plot, right? We're using dots to represent cause and effect between 2 different variables. Yesterday we did a time series graph, which represents, how are things changing over time. So our variable 1 is the variable of time. Another variable is whatever other thing we're studying. Okay. They're calling that a run chart here, but we called it a time series graph. But it's the same idea. Okay. Bubble chart, which you maybe would think of as like a dot plot. Okay, but there's all these other types of multivariable charts that we could use. Okay, we're not going to get into more of this website, at least not for right now, but that's kind of some basics. For today, we're really just going to focus on stem and leaf plots, which are pretty simple plots to make. So a stem and leaf display is a method of exploratory data analysis that is used to rank, order, and arrange data into groups. Okay, great. We know we did yesterday frequency distributions. So that was just a frequency table. We created histograms to represent those frequencies. Excuse me. But what this is saying is the negative of a histogram is we lose the specific values. In a histogram, we just know, hey, how many numbers were between 1 and 9. Okay, we can tell how many numbers there were, but we don't know the specifics. Were all those numbers primes? Was one of them a 2, one of them a 3? So that's a negative drawback of a histogram is we lose the specifics of the data values. Okay, so here's an example. Many airline passengers seem weighted down by their carry-on luggage, but just how much weight are they carrying? So we want to create a stem and leaf plot that will kind of separate our data into intervals, just like we were doing with the histogram, but we can see the specific values still. Okay, so an example, I'm going to draw this one, and you guys maybe have seen this before, but I usually have a stem, and then I have a leaf. Okay, and we kind of have a separation between these two. All right, but then I want to chunk my data. Oh boy, oops. I'm writing on my computer, so they'll see how this goes. I'm still going to have intervals, just like we do with the histogram. But we're not going to be as worried about how we get those intervals. You know, yesterday or the other day, we were talking about taking your min and your max, subtracting them, dividing by how many weights or classes you want. And we don't need to worry about that. In this case, the most often display for a stem and leaf plot is my stem is the tens place, and my leaves are the ones place. So in this example, I'm running out of room, but 0, this means there is no tens place. So on a leaf, I'd have 0, 0. That just represents the number 0. Okay, so I could cross these off. I kind of want to put them in order if possible. So it looks like my next value is 3. Hopefully I'm not missing one. So that's a single digit number. I think I'm blind, but I don't see any other single digit numbers. So I'd move to the tens places. So I know I see some 12s. I don't think I see any 11s. So here's a 12. So that would be a 2. Notice a 1 and then a 2. That just is equal to this value of 12. Here's another value of 12. Okay, I can continue on and try to get all my places. I'm going to pause my video and kind of crush through some of these so you don't have to just listen to me suffer trying to find the right value. So I'm going to pause recording here for a second. Okay, so you can see I didn't do the 40s and 50s, but there's kind of a sloppy mess of what this is looking like for my stem and leaf plot. But if I continued the 40s and 50s, what if you kind of turn your head sideways and look at this thing, you pretty much have, if you can see, a bar graph or a histogram. Okay, it's showing the distribution of all of the values, you know, how many are in the single digits, 10s, 20s, 30s. It's just doing it as a horizontal display, but it's still showing the distribution of how much data is where. But the benefit is we get to see the individual values. We get to see that there's 3 21s or 4 32s, you know. So it's better in that regard that we don't lose the individual characteristics of the data. Okay, so that's an example of a stem and leaf plot. If I continue here, maybe, there we go. Okay, so this is all the carry-on luggage. I'm gonna skip over this. I'll start it, but again, I'm not gonna go through the whole example because this is fairly simple. I hope we get it. But we do need to talk about, well, what do we do with these, you know, 3-digit numbers? Well, you do it the same way. Okay, I'm still gonna have my stem. Okay, I'm still gonna have my leaves. Okay, and then the only difference is now I have some numbers in the 80s. So there's an 8 and a 3. And when you guys are doing this, to be honest with you, this is a nightmare for me trying to sort through all these numbers and then figure out if I missed any or put them in order. That's the worst. So use your lists on your calculators. Use your list, put all these in a list, sort it so they're all in order. That way you don't miss anything and you don't have to worry about if you messed up the order of anything. That's how I would do it, but each their own, I guess. Then I got the 9s. I can see I got a 92. I hope I don't miss any, but I probably will. A 97 looks like it's next. A 98 I see. A 99. Okay, I think I got all the 90s. Now, what do we do with the hundreds? Well, guess what? You have 10 tens. Again, this is just the tens place. So everything in the single hundreds would be here, like 101. That's 101. If I got 103, I see. I'm probably going to miss some. There's a 3. I got a 104. And I could keep going. You get the idea. I missed a 102 in there. Then when I get to 111, for example, I just say that's 110, right? 11 times 10 is 110. I need one extra. So there's 111. Ooh, I missed a 0. There's 110. There's 111. So you get the idea. When you have 3 digits, we are still just writing how many tens we have. Okay. If we got into like the thousands, we would make them maybe a different way of, representing it. Or to be honest, a stem and leaf plot when you got numbers that big is not very common to use it anyways. You use something else to represent the data. Okay, so that's a really quick rundown on stem and leaf plots. They're super easy. I'm not going to talk more about it because I hope we get it. But that's all you're doing in 2.3 is creating stem and leaf displays and then answering some questions related to them. Okay, so here's the kind of a last second thing of how you create a stem and leaf plot. But I think that's pretty straightforward or pretty obvious. So your assignment for 2.3 is posted online, and that's all. Adios.